Okay, so we've also found a marker that is hopefully working. So we're going to start with ax squared plus bx plus c equals 0. We're going to try to derive our formula in general now. So any guess for what we should do for the first step? No, actually, before I do that, let me just put it over here, that for x squared plus bx plus c, we just found the roots were negative b plus or minus the square root of b squared minus 4c.
C
over 2. So now we want to solve it in general, because we might have like 2x squared plus 5x minus 7 equals 0.
Yeah.
Well, I would divide by a.
Okay?
Yeah.
So I get x squared plus b over a, x plus c over a equals 0. All right?
Then we can create the same identities for R and S.
Okay,
So
so
you have R plus S, the roots are negative b over a,
negative b over a.
and you have RS equals c over a.
Okay, good. So here, even though our expression is a little more complicated, we still know from the work we did before that the sum of the roots is minus b over a, and the product of the roots is c over a, the constant term.
Yeah.
Okay? So what should we do now?
Well, let's go through the same steps. We know that
Well,
both of
I'll use some room over here.
the roots are they're equidistant from the vertex of parabola, which is, we can call it distance z.
Uh-huh.
So we know
So I would say r equals what?
would the first step to say that r plus s over 2 would be equal to z?
Well, r plus s over 2 wasn't equal to z. What was it equal to? Or what would it be equal to here?
It's equal to b over 2a.
Yeah, so r plus s over 2, so their average is negative b over 2a. So what do we say r might be equal to then?
Minus.
What was the idea when their average was, we knew what their average was?
We had, I think it was something involving z over 2. We used,
Well, we said we had two numbers and we knew what their average was. And so what could we say about those two numbers if all we know is their average?
we know that each of them is half of their difference apart away from their average.
Okay, and how would you say it?
So I'd say that 1 is a constant. Average plus the constant is the average minus the constant.
Yeah, one's just a little bit above it, or sorry, not necessarily a little bit. One's above it by some amount, and the other one is below it by the exact same amount. Minus. And so why is that true?
Because we know that the average is on the plane is directly in between them.
Yeah.
Cut
So
them in
we
half.
get this relationship. Okay. And so now that we have this relationship for the little amount above and below the average, what do we do?
We can put it back into this equation here.
Okay. So we do the product, and what is the product? R times S here.
We get b squared over 4a squared
E squared over 4a squared.
minus c squared.
C squared equals C. So C equals, so Z,
Z equals b squared.
the square
Yes.
root of B squared.
Over 4a squared minus c.
Sorry, I forgot this is C over A.
Yeah, because
Oh,
we're dividing.
Yeah. Minus C over A. And then I guess maybe I'll go back to over here. Why don't I simplify this first? So to get a common denominator, I need an a and a 4. So I
Yes.
get z equals the square root of
B
b
squared
squared minus
4ac.
And then I have a 4a squared on the bottom of the square root.
Yep,
So what
so
does
that
that
can
turn
be
into?
2a.
2a. And so that tells me that the first root and the second root are negative b plus or minus square root of b squared minus 4ac
Over 2a.
over 2a.
Wow.
So it's definitely some complicated algebra.
Yeah.
But really, the main math ideas are about the sum and product of the roots, and this idea about an average when you have two numbers. The average is in the middle of them, so you have the same amount above and the same amount below.
Yeah.
And just with those two ideas, we can derive the quadratic formula.
I would say that's probably less complicated than completing the square.
Yeah. What do you think?
I'd say about the same.
About the same?
Neither one is particularly complicated.
Yeah, it's a pretty neat idea though. This is it's neat to have a second way to remember how to do this.
Yeah.
All right, good job this morning, guys.